Good morning students, this is Latif sir. In this video I am going to start the chapter 5 of class 10 chemistry. The topic is mole concept and stoichiometry. This is the 5th chapter of class 10 chemistry and the reduced syllabus I have given here. According to the reduced syllabus, you have to read the relation between vapor density and molecular mass, deduction of empirical formula and molecular formula, percentage composition and masses of combining elements. This is the reduced syllabus. Maximum portion from this chapter are excluded from the syllabus. Okay, so I have given the syllabus of this chapter. So first topic is relation between molecular mass and vapor density. You know what is molecular mass or relative molecular mass. You have already studied in class 9 how to calculate molecular mass or relative molecular mass. Okay, in simple word, molecular mass or molecular weight is the mass of a single molecule. Okay, so and how can you calculate this molecular mass or relative molecular mass of a compound? You can calculate the molecular mass of a compound by adding the relative atomic masses of the various elements, various atoms present in a this molecule. Okay, so just you have to add the atomic masses of different elements present in one molecule of that compound. Okay, for example, H2SO4 sulfuric acid. And what is the molecular rate of sulfuric acid? You know, atomic mass of hydrogen is 1, atomic mass of sulfur is 32, atomic mass of oxygen is 16. Okay, so in one molecule of sulfuric acid, two hydrogen atoms are there, one sulfur atom and 4 oxygen atoms. Okay, so what is the relative molecular mass or molecular weight of sulfuric acid? Just add the atomic masses of two hydrogen atom, one sulfur atom and 4 oxygen atoms. Okay, so two hydrogen atoms, so 2 into 1, because atomic mass of hydrogen is 1. For one sulfur, 1 into 32. For 4 oxygen, so 4 into 16. So total molecular mass of sulfuric acid is 98. Okay, so molecular mass of sulfuric acid is 98. Very simple calculation. You have to calculate relative molecular mass or molecular weight of a compound, of a molecule. You have to add the atomic masses of different elements present, different atoms present in one molecule of that compound. Okay, now see what is the relation between relative vapor density and molecular mass. First you have to know what is relative vapor density. Okay, and relative vapor density, it is defined, it is the ratio between the masses of equal volume of gas or vapor and hydrogen under the same condition of temperature and pressure. Okay, so relative vapor density is the ratio, relative vapor density of a gas is the ratio of masses of equal volume of the gas and hydrogen under the same condition of temperature and pressure. So relative vapor density or Vd, okay, Vd, vapor density, is equal to mass of equal volume of that gas divided by mass of equal volume of hydrogen gas under similar condition, similar temperature and pressure. Okay, this ratio is known as relative vapor density of the gas. Relative vapor density of a gas is equal to mass of that gas, mass of equal volume of that gas at similar condition divided by mass of same volume of hydrogen gas under similar condition. And the relation between relative vapor density and molecular mass of a gas is 2 into relative vapor density is equal to molecular mass of the gas or vapor. Okay, so relative molecular mass, that is m is equal to 2 into vapor density, 2 into Vd. This is the relation. You have to read this relation. Okay, so relative vapor density and relation between relative vapor density and molecular mass of a gas is 2 into relative vapor density is equal to relative molecular mass of the gas or vapor. Okay, so the relative molecular mass of a gas or vapor is twice of its vapor density. For example, relative vapor density of chlorine gas. Chlorine atomic number is 35.5. Cl2 chlorine is atomic mass is 35.5 and chlorine gas means Cl2. So its molecular mass is 35.5 into 2, that is 71. Okay, so chlorine gas molecular mass will be 71 and its vapor density will be 71 divided by 2, that is 35.5, because relative molecular mass is equal to 2 into vapor density. Okay, very simple calculation. Now see percentage composition calculation. You have already studied in class 9 first chapter, language of chemistry, about percentage composition calculation. What is percentage composition calculation? First you have to know what is percentage composition. Percentage composition of a compound is the percentage by weight of each element present in it. Percentage composition of a compound is the percentage by weight of each element present in it. And mathematically you can calculate percentage composition of an element in a compound. You can calculate percentage composition of an element in a compound using the formula percentage composition is equal to total weight of that element present in the compound divided by molecular weight of the compound into 100. Mathematically you can calculate percentage of an element in a compound using this formula. Percentage of an element is equal to total weight of that element in one molecule of that compound divided by gram molecular weight of the compound into 100. For example, I am explaining with an example. Calculate the percentage composition of various elements in sodium carbonate. Sodium carbonate formula is Na2CO3. In sodium carbonate, you have to calculate the percentage composition of sodium, percentage composition of carbon, percentage composition of oxygen. Okay. So first you have to calculate molecular weight of the compound of the molecule. Molecular weight of sodium carbonate is, here atomic masses of different element is given. You can see sodium atomic mass is 23, oxygen atomic mass is 16, and carbon is atomic mass is 12. So first you have to calculate relative molecular mass or relative molecular weight of Na2CO3. In Na2CO3, 2 sodium, so 2 into 23 plus 1 carbon, so for 1 carbon atomic mass is 12 plus 3 oxygen, so 3 into 16. So total relative molecular mass of Na2CO3 is 106. Okay, 106 is the total molecular mass of Na2CO3. Now see, in Na2CO3, in 106 gram Na2CO3, mass of sodium atom is 2 sodium, so 2 into 23, that is 46 gram sodium is present in 106 gram of this compound. Okay, so 106 gram of sodium carbonate contains 46 gram of sodium, then 100 gram of sodium carbonate contains 46 into 100 divided by 106. So using the formula you can calculate percentage of sodium will be equal to mass of sodium, that is 46, divided by molecular weight of the compound, that is 106 into 100. Very simple. And the percentage of sodium will be 43.4 gram, 43.4%. Okay, now see calculation of carbon in sodium carbonate. I have already calculated the molecular weight of sodium carbonate, it is 106. And now see, in 106 gram sodium carbonate, carbon present is 12 gram, only one carbon atom though. So mass of carbon atom is 12 gram is present in 106 gram sodium carbonate. So percentage composition of carbon will be equal to mass of carbon, that is 12 gram, divided by mass of molecular weight of the compound, that is 106 into 100. So 12 by 106 into 100, this is the percentage composition of carbon. Okay, similarly you can calculate percentage of oxygen in one molecule of Na2CO3. In one molecule of Na2CO3, amount of 3 oxygen atoms are there. So 1 oxygen means 16. So 3 oxygen means 3 into 16, that is 48. So 106 gram Na2CO3 contains 48 gram oxygen. Okay, because 3 oxygen atoms in one molecule, so 106 gram Na2CO3 contains 48 gram of oxygen. So then 100 gram Na2CO3 contains 48 divided by 106 into 100. You can calculate using the formula, or you can also calculate using unitary method. Okay, so according to the formula, percentage of oxygen will be equal to mass of oxygen, that is 48, divided by molecular mass of Na2CO3, that is 106 into 100. Okay, that is 40 45.3. This is the percentage of oxygen. Okay, one more example is given. In this compound, in sodium carbonate, in washing soda crystal, washing soda means Na2CO3.10H2. In the question, find the percentage mass of water in washing soda. So you have to find out the percentage mass of water in sodium carbonate dot 10H2 in washing soda. So first you have to calculate the total molecular mass of washing soda, Na2CO3 dot 10H2. So in Na2CO3, 2 sodium, 1 carbon, 3 oxygen and 10 water molecules. Okay, so for each sodium, 23 atomic mass, so 23 into 2 plus 1 carbon, so plus 1 carbon, for 1 carbon 12, and 3 oxygen, 3 into 16, atomic mass of oxygen is 16, and now 10 H2, so 10 into, for H2O, atomic mass of hydrogen is 1, so for 2 hydrogen, 2 into 1 plus 1 oxygen, it is 16, so 10 into 2 plus 16, that is 10 into 18. Okay, so 106 plus 180, that is 286. Total mass of one molecule of Na2CO3 dot 10H2 is 286. Okay, so in 286 gram Na2CO3 dot 10H2, amount of water is 180 gram, because 10 water molecule, 1 water molecule means 18, so 10 water molecule means 180. So percentage of water is 180 divided by total molecular mass, that is 286 into 100. Percentage of water, this is the percentage of water, is equal to 180 divided by 286 into 100. Very simple calculation. Okay, and the answer is 62.9%. Okay, so in one molecule of Na2CO3.10H2, percentage of water is 62.9. Percentage of, it is percentage of water. Okay, so now next topic, empirical formula. Empirical formula of a compound. Empirical formula and molecular formula you have to calculate. So first you have to know what is empirical formula. Empirical formula is the simplest formula of a compound. Simplest formula. Empirical formula of a compound is the simplest formula which gives the simplest ratio in whole number of atoms of different element present in one molecule of that compound. Empirical formula is the simplest formula of a compound which gives the simplest ratio in whole number of atoms, simplest ratio of atoms of different element present in one molecule of the compound. For example, in hydrogen peroxide, formula of hydrogen peroxide is H2O2. H2O2. In one molecule of hydrogen, number of hydrogen is 2 and number of oxygen is also 2. So the ratio, the number ratio of hydrogen and oxygen atom is 2:2, that is 1:1. Okay, so according to the simplest ratio, what is the formula of hydrogen peroxide? The formula of hydrogen peroxide is HO. Okay, this is the according to the simplest ratio in hydrogen peroxide. According to the simplest ratio, the formula of hydrogen peroxide is HO, which is the empirical formula of hydrogen peroxide. Okay, so empirical formula of a compound is the simplest formula which gives the number of atoms, simplest ratio in whole number of atoms of different element present in one molecule of the compound. Similarly, for glucose, uh, the molecular formula of glucose is C6H12O6. Okay, so in one molecule of glucose there are 6 carbon, 12 hydrogen and 6 oxygen. So the ratio is 6 is to 12 is to 6, that is 1 is to 2 is to 1, and this is the simplest ratio. So according to the simplest ratio, what is the simplest formula of glucose? It is CH2 and O, and this is the empirical formula of glucose. Okay, empirical formula of glucose. And the mass of this unit unit CH2O is known as empirical formula mass of glucose. Okay, so what is empirical formula? It is the sum of atomic masses of various atoms or various elements present in the empirical formula of the molecule. Empirical formula is the sum, empirical formula mass or empirical formula weight is the sum of atomic masses of various elements present in the empirical formula. Okay, so according to the empirical formula, the mass of the unit is known as empirical formula mass. Now I'll discuss how to calculate the empirical formula of a compound. Remember that the empirical formula of a compound is not the actual formula of the compound of the molecule. It is the simplest whole number ratio of different atoms present in one molecule of that compound. So empirical formula is not the actual formula. Actual formula of a compound of a molecule is the molecular formula. Okay, so now I will discuss how to determine the empirical formula. Okay, I am explaining this, how to calculate empirical formula with an example. This type of question will be given in the exam. You have to calculate empirical formula. So find the empirical formula of the compound with the following percentage. Okay, so during calculation of empirical formula of a compound, in the question percentage composition of different element will be given. For example, in this question percentage of zinc is given 47.8 and percentage of chlorine is given 52.2. In first question the compound is made up of zinc and chlorine, and in this compound percentage of zinc is 47.8 and percentage of chlorine is 52.2. Okay, so first you have to make some column. In one column you have to write name of element, in second column percentage of composition of that of the elements, in third column you have to write the atomic masses of different element present in the molecule, and in next column you have to write atomic ratio or number of atoms, ratio of number of atoms, and in last column you have to write simplest ratio. This is the simplest ratio. So in this compound zinc and the compound made up of zinc and chlorine, first I have written the element zinc, which is present 47.8%, and atomic mass of zinc is 65. So the atomic ratio of zinc is 47.8 divided by 65. This is the atomic ratio of zinc, and this value is 0.73. And similarly for chlorine, percentage of chlorine is 52.2 and percentage of atomic mass of chlorine is 35.5. Percentage of chlorine is 52.2 and atomic mass of chlorine is 35.5. So atomic ratio of chlorine is 52.2 divided by 35.5. So the atomic ratio of chlorine is 1.46. So how to calculate atomic ratio? You have to divide the percentage composition of the element by its atomic mass. Okay, and then you will get the atomic ratio. Now you got two atomic ratio of zinc and atomic ratio of chlorine in this compound. Then you have to divide both this value with the smallest number. So in this case smallest number is 0.74. 0.74 is the smallest number. You have to divide both the values by 0.73 to get a smallest simple whole number. Okay, so divide 7.73 by 7 divide 0.73 by 0.73, you will get 1, and similarly you have to divide 1.46 by 0.73 to get whole number, and the whole number is 2. Okay, so in this compound the zinc is, according to the simplest ratio, zinc is 1 and chlorine is 2. So the empirical formula is ZnCl2, 1 zinc and 2 chlorine. Similarly, more example is given. The compound formed by magnesium, sulfur, oxygen and water. In this compound, magnesium is present 9.76%, sulfur is 13.1%, oxygen is 26.01% and water is 51.22%. So you have to make different columns, okay, separate columns. In first column you have to write name of different elements, symbol of different element. So elements are magnesium, sulfur, oxygen and water. According to the question, percentage of magnesium is 9.76, percentage of sulfur is 13.01, percentage of oxygen is 26.1 and percentage of water is 51.22%. And then you have to write their atomic or molecular mass. Okay, for water you have to write the molecular mass, and for different element, different atom, you have to write atomic masses. Okay, atomic mass of magnesium is 24, atomic mass of sulfur is 32, atomic mass of oxygen is 16 and molecular mass of oxygen is 18. In next step, to get the ratio of atoms or ratio of molecules, you have to divide the percentage composition by its atomic mass or molecular mass. Okay, so atomic ratio of atoms or molecule for magnesium, atomic ratio is 9.76 divided by 24, the value is 0.0406, and for sulfur atomic ratio is 13.01 divided by 32. So the ratio of sulfur is 0.406. Similarly, for oxygen the ratio is 26.01 divided by its atomic mass, that is 16. So 26.01 divided by 16, that is 1.625. And molecular ratio of water is mass of percentage of water, that is 51.22 divided by 18. So the ratio is 2.86. Okay, and the smallest number among these values, among these atomic ratio, smallest number is 0.46, 0.0406. This is the smallest number. So you have to divide all these atomic ratios, by the smallest number 4.406 to get smallest whole number. Okay, simplest whole number. To get simplest whole number ratio, you have to divide all these atomic ratio by the smallest number. So the smallest number among these values is 0.406. Okay, so after dividing all these value by 0.406, you will get magnesium simplest ratio is 1, sulfur simplest ratio is 1, oxygen simplest ratio is 4, and for water simplest ratio is 7. So in this compound, 1 magnesium, 1 sulfur, 4 oxygen and 7 water molecule is present. So empirical formula is MgSO4.7H2. Okay, and one more example is given. Okay, try to solve this problem. Okay, and how to calculate molecular formula I will discuss in next video. Bye students.